Okay, welcome to the helicopter lab video. This is just a quick little video that overviews the helicopter lab, Mr. Sellers' class, and basically what I'm going to do is provide the data for you, and you can calculate and graph and answer all your analysis questions after you have the data collected. And this hopefully will be helpful to you. So hopefully you've also went to Google Classroom or Edmodo and picked up my copy of the or your copy of the lab, or maybe you got one from me, which is also fine. So we call this the Falling Object Lab, and also known as the Helicopter Lab. Now you'll notice that there are multiple procedures here, and again, these aren't questions. These are things that tell you how to do the lab, essentially. So over on this side, you'll see your data analysis questions. Your data analysis questions can be answered after your data is calculated and graphed. So if you flip it over on the back, I already have my helicopters made, so I'm not going to cut these out. I also went ahead and measured the wing width and the wing length, and I calculated the surface area of all of my helicopters. So that data is already on here. Get that a little bit closer. Hopefully you can see that. 8 times 7, 56. 8 times 11, 88. And then helicopter 3 is the same as helicopter 1. We just add 2 paper clips on it to increase the mass. So I'm going to go collect the data real quick, and then after every single helicopter's data, I will bring it over here and let you see it on the camera. So starting with the little helicopter. Okay, I've got my timer, I've got my helicopter, got my pin ready. I'm dropping it from a height of 200 centimeters, which is 2 meters, and I want to do that consistently, so that's what we call a control in the lab, right? We keep that exactly the same. So what we're going to be changing is our helicopters, so those are independent variable. We'll come back to that when we get to the lab, or the graph, sorry. All right, so I'm starting with a little helicopter. My 2 meter mark. Timer didn't work. Timer didn't work. Lab mistakes. Here we go. Worked. 2:04. 2.04 seconds. 2.04 seconds. Mistake, but we're going to keep it anyway. 2.19. 2.19. You don't want it to hit the wall, so we'll pull it a little bit further away to make sure it doesn't do that. Still do it. 1.84. 1.84. .98. Being very consistent data. That's good. We're all right about 2 seconds. 2.09. 0.09. Okay. Done with the little helicopter. I'm going to bring this over here and let you take a look at it. So here are my data points. You have 2.04. 2.19, 1.84, 1.98, and 2.09. Now your next step is you're going to have to calculate the velocity. So what you do for velocity, and it's kind of revealed right here, is you divide the distance divided by the time. So the distance, and I circled it right here, the distance is 200 centimeters every time, and you're going to divide it by the seconds. And this is going to give you a velocity. After you calculate all of 5 of these velocities, you're going to add these up. You're going to add them up and divide by 5. to give you the average data. Now you'll only be graphing the average data. So I just circled that one because again, this is the only one you'll be graphing. So you got to add all these up and divide by 5 to get this average here. So we're going to do that for 2 more helicopters. So let's go ahead and collect our data for our next 2 helicopters. Starting with going on to the big. We've already collected the data for our small helicopter. Big helicopter trial 1. 2.61. 2.90. 2.48. 2.64. 2.60. 'There's those data points again for the big helicopter. 2.61, 2.90, 2.48, 2.64, and 2.60. And just like you did up here, you're going to calculate your velocities by dividing the distance divided by time. And then once you get all these velocities calculated, you're going to add all of them up and divide by 5 to get your average again. Remember, you're graphing just your averages. Okay, let's go collect data on our last helicopter. So for our last helicopter, we used the little helicopter, and it says it right here, little helicopter with paper clips. So we're going to attach 2 paper clips to it to provide a little bit more mass to this helicopter. I'm attaching the paper clips right down here. You don't want to put them on the wings because it hinders the way it flies. So we don't want that. Got my helicopter, got my masses, ready to collect data. .56. 1.57. Wow, that's close. That's very close data. Okay. 1.57. Are you kidding me? Wow. That is really close data. Whoever's collecting this data must be outstanding at collecting data. 1.54. 1.54. Wow. That's the best data I've seen. But then again, look at the source. Okay, so now I'm going to show you this data up close and personal. You have 1.56, 1.57, 1.57, 1.54, and 1.54. So again, you're going to take the 200 centimeters divided by the time to give you your velocity in centimeters per second. After you get all those calculated, you're going to divide by 5 to find your average, add them up and divide by 5 to find your average for helicopter 3. So now let's talk about the graph. I'm going to get my camera settled here. Okay, sorry. So, what did we change on purpose in this lab? Well, we changed the helicopters. So when you change something on purpose on a lab, it's what's called the independent variable. So, and the independent variable is always on the x-axis. So you're going to graph helicopter 1, helicopter 2, and helicopter 3 down here on your x-axis. So what data did we actually collect and calculate? Well, we collected the time, and then we calculated the average velocities, right? So we're going to graph on our y-axis the average velocities. So you'll make 3 different bars, right? A bar graph for the average velocity of helicopter 1, the average velocity for helicopter 2, and the average velocity for helicopter 3. And then once you have your numbers labeled out, of course, and your bars drawn, then you'll be ready to answer your analysis questions. So analysis questions should be after your graph. That's going to make it a little bit easier to kind of think about what exactly happened. So if you have any questions further than this, let me know in class, and hopefully I'll be able to address those questions. So see you in class.